Hello everyone, welcome to my programming club. I hope everyone is doing fine. Today we will be solving another daily Leetcode problem. The problem's name is find mode in binary search tree. So we have to find the element or say value in the binary search tree which is occurring a maximum number of times. So given a root of a binary tree which is consisting of duplicate values, binary search tree basically, return all the modes most frequently occurring elements in it. Okay, if there the tree has more than one mode, return them in any order. So let's say 2 is occurring twice and 3 is occurring also twice, then in that case you will be returning 2 and 3. What I mean to say is, let's say the tree is something like this. Pardon me if I'm not satisfying BST property as of now. So let's say these two nodes are of one particular value and these two nodes are of the particular value and this is some other value. So as you can see, the green ones are occurring twice and the yellow ones are occurring also twice. So it's the maximum frequency the nodes are occurring. So your answer will be containing green ones and yellow ones. Okay, basically their values. Okay, let's say value was 2 and its value was 3. Okay, so this is what you have to return. Assume that BST is defined as follows. Binary search tree, those of you who are not familiar with what binary search tree is, the left subtree of a node contains only nodes with key less than or equal to the node's key. For example, let's say it's something like this: 1, 2, 3. Okay, so you can see the left key is smaller than the root, and all the values in the left subtree, this subtree, let me change the color, this particular subtree are also lesser than the root or say current root. And similarly for the right subtree, all the values are greater. Okay, so then the current root. So this is what a binary search tree is. The right subtree of a node contains only node with keys values that are greater than or equal to the node's key. Okay, equality is also considered here. Okay, so both left and right subtree must also be binary search trees. So this subtree should be a BST and it should be a BST. All the properties mentioned above, these two properties should be satisfied in both of them. So that's what a BST is. Okay, now let's have a look at the constraints. The number of nodes in tree is in the range 1 to 10 raised to power 4. Okay, so there should be and there will be at least one node in the tree, and at max there can be 10 raised to power 4 nodes. And the value of the node ranges from 10 raised to power 5 to 10 raised to power 5. And there is a follow-up also. Can you do that without using extra space? Okay, so we are asked to derive a solution that will be running in constant space, ignoring the space that would be occurred due to recursion stack. Okay, if you are using recursion, then that space will be ignored. Other than that space, you should not be using any extra space. This is a follow-up. So we will be discussing two approaches for it. One will be a naive approach that will be sufficient to, get the solution accepted. And another will be a approach in which there will be no extra space other than stack space for recursion. So in the naive approach, what we will do is, or let's discuss the naive approach first. In this approach, what we will do is we will do a traversal of binary search tree. Uh, you can choose any type of traversal in order, P order, or any type of traversal of your choice. There are some other techniques also like Morris traversal and other ones. So you can choose any of them and you will just use a map to store frequency map for each node. And you will find out what is the maximum frequency and all the nodes that are occurring maximum frequency times will be stored in your final result array. All nodes occurring max frequency times will be returned. Okay, in the as a array. Okay, or say vector array in Java and vector in C++. So this is one approach, and in the traversal you will be visiting each node once, so the time complexity will be order of n, where n is here the number of nodes in the tree. Okay, and space complexity wise, it will be at max order of n. Okay, which will be used for, if you ignore the recursion stack, frequency map. Okay, and now let's discuss another approach that we will be implementing for the follow-up question. Constant space approach. Okay, so constant space approach, ignoring recursion stack space. So how we will be going with this approach? We will be using a little property of binary search tree, BST property, that you, if you do a in-order traversal, those of you who are not familiar with these three traversals, I will be providing links particularly for this in-order traversal that we are using in the constant space approach. Okay, so links will be provided for them. So what happens is, if let's pick a BST from the examples, I think this would be fine. First of all, let me describe the property. If we do in order traversal, of a BST, then it will be in sorted form, sorted order. Okay, and it will be basically in increasing order. The node value that will be coming up in order traversal will be in sorted order, ascending order. So if you do the in order traversal of the example that we have taken, this example, then it will be, let me increase its size. Yeah. So first your root will be traversed. Okay. First your left child, which is nothing here. Then your root, so 1. Then your right subtree of your current root. In the right subtree also, first its left subtree, which is 2. So it's being covered. And then this 2. Okay. So it will be something like this. So as you can see, it's sorted in increasing order. Now let's say if you are given this particular array, let's say 1, 2, 3, 3, 3, 3, and then 4, 4, 4, 4, something like this. Okay. Then if I uh, ask you, what is the maximum frequency for a element, for any element, then you can easily do it in constant space. You will just keep a count variable and another max count variable and one variable, let's say previous value. Initially it will be set to a value that is not present in your range. So the range of values is ranging from minus 10 raised to power 5 to 10 raised to power 5. Let's say we give it 10 raised to power 5 plus 1. Okay, initial value. So as soon as the previous value is not same as the any current value, let's say this is the current value. Let me quickly change the color. Then your count value will be set to 1, and if it's same to the current value, then you will simply increase your count. For example, let's say you were here, your previous value was 2, so current value will be 1. Then you move to this point, and then current count will be 2 because previous and current value are same. So it will be something like this. Okay, 1, 2, 3, and then 4. Easily you can say that this is the maximum frequency. And then you can do another traversal, second traversal. And then you can see whichever element is occurring max frequency number of times, you will be storing that element in your result array. Okay. Here the only element which was occurring max frequency times was 4, which was occurring 4 times. So answer will be 4. So this is how we will be approaching the problem, doing in order traversal basically twice. And yeah, that's the approach. So let's quickly implement it. I hope it's till now it's clear to you. If it's still not clear, I think it will be more clear in the implementation part. So let's implement. Okay, first of all, we will be needing to store maximum frequency somewhere. Let give it a value of 0 for now, and let's make these values private. Okay, and then current count, or let's say frequency count. Okay, and previous value, let's give it some value out of the range of the node values. Let's give it 10 raised to power 5 plus 1. So 3, okay, 10 raised to power 5 plus 1. I think, yeah, it's 10 raised to power 5 plus 1. Okay, so then we will declare a function or say method. Uh, let's declare a list first, since we do not know how many times will there be one mode or more than one mode. So let's declare the modes array list. Okay, or we can initialize it in the main function that is being provided here, and currently this will be set to null. Okay, so now what we will do is we will make the in order traversal function or declare it and find out the maximum frequency. Finding out max frequency. Okay, so max frequency, or say calculate max frequency. And your root will be passed. Rest we do not have to pass anything. So let's declare the function. Let's make it private. Calculate max frequency. Node, and let's call it root. Okay. If your root's current value is null, then you will be returning from there. And firstly, you will be visiting the left side of current root. So for that, you will be calling calculate max frequency root dot left. Okay. Then you will visit the root, and here you will do all the calculations for counting frequency, and do calculations for counting frequency of current root. So if previous value, I think, okay, I have typed previous value wrong here. So previous value is equal to current root's value, root dot val it is, I think. Yeah, well. So if that's the case, then you will be incrementing your frequency count by 1, And if that's not the case, in that case, your frequency count will be set to 1 and your previous value also be changed to root.val. Okay. And you will keep updating your max frequency. Max frequency it is, I think. Yeah. Max frequency count. Okay. So this max frequency is being updated. We have to take the maximum of frequency count and the max frequency. So then we will be traversing the left side of the current route, right side of the current route, sorry. Okay, so calculate max frequency and root dot right. Okay, now you will be having max frequency. Choose all the nodes that are occurring max frequency times. Okay, so let's call this choose nodes. Okay, it will also be an order traversal like this one. Of BST is sorted in increasing order. This property is being used for arriving or deriving the solution, the logic, the core logic of the solution. Based upon this property of BST. Okay, so choose nodes, root will be passed, and at last you will be converting your, let's say, uh, modes array list to result. Before that, let's declare and define the choose nodes function. Private, I missed the return type here. Okay, choose nodes it is. Yeah, choose nodes. 3 node root. Okay, so if this will be pretty much same, so we will be copying that. Here, instead of updating the max frequency, if your frequency count is equal to the max frequency, then that node will be added to. I think instead of list, we should have used a set here so that only unique values will be there. Okay, so let's change it to the hash set. Think it will be not okay, it will not matter because anyhow whenever the maximum frequency will be reached, only that one will be added. So what was the name of the list? So this list is to be returned, or this integer array is to be returned. So I am not counting it as extra space. Okay, modes. So modes dot add roots value. Okay, and that's pretty much it. Then we will be returning your list, convert it to a integer uh, array. So I think there is a function how to convert array list to integer array. I think stream library uses some kind of function to convert it. Internet is a little bit slow, so there should be some function here. Yeah, it's stream map to int. So we can use that. It will save us some time of converting this nodes array list. Okay, modes dot stream map to int and to array. So let's have a quick look if we have done any typing mistakes before submitting the solution. I think everything should be fine. Choose nodes. Okay, here it's choose nodes, and here also it will be changed. We forgot to change here. Okay. So it's a good idea to check before submitting. Yeah, I think rest of the things should be fine. Let's try to submit for sample test cases before submitting for final evaluation. It's giving a wrong answer in one case. Case 2. In that case, your maximum frequency is not 1. Okay, we are doing a little mistake here. That we are not changing the value of previous value once we are done with this function. Which function? To calculate maximum frequency. So we should be changing that before calling choose nodes, since it is also using the same value, previous value. So we should be resetting the previous value. So previous value will be 10 raised to power 5 plus 1. I think it should be fine now. Yeah, it's getting accepted now. Okay, so let's try to submit. for final evaluation. As you can see, it's getting accepted for the final test cases. So that's how we will be solving the problem. Okay. So I will give a quick recap what we have used here, what property. Basically, this property is being used. If we do in order traversal of a BST, then it will be sorted in increasing order. Okay. So this property is used to arrive at a constant space approach. So the time complexity wise, it will be every node will be visited only once or say twice. So overall order will be order of n, and here is the number of nodes. Okay, and space complexity wise, if you ignore the recursion stack space, then it's constant. Ignoring. Okay, so we are also not counting the space that will be required to store these nodes, since it is asked, we are asked to return. Okay, so yeah, and if anyone is having any doubts in the approach or any part of the solution, then feel free to ask the doubts in the comment section. I will be more than happy to answer. Thank you for watching.